Good afternoon, everyone. We all are surrounded by data. We are living in a data revolution. And I'm here to talk to you today about how we can use this data revolution and the deluge of data that we are living in to perhaps tame the deluge in the sea levels. As director of the NSF HDR Institute, these are exactly the questions that we are trying to tackle and address, looking at the model and data revolution in our polar regions. Now, looking at several examples that you may have seen around you, some examples pop up right away. You may have seen images such as these, where the foreign minister of Tuvalu was standing in the middle of the water, giving a speech for COP26. This was a poignant image that resonated with many of us. This was land where people lived and now surrounded by water. Closer to home in the United States, some of you may remember this image from the Yellowstone National Park, where there was a flood, which was supposed to be a 1,000-year event, where the northern region of the park was closed, and eventually the entire park was closed. And even more closer to home, we have seen things in Maryland. We have seen things in Crisfield, where the land is sinking. We have seen things in Ellicott City, where we have seen multiple 100-year, 1,000-year events. And these are not called 1,000-year events because they happen once in 1,000 years. There's a very, very low probability of happening, but they're happening more and more often. And if you look closely at the Society of Concerned Scientists and their research, you will see that many of our communities could be covered in water and could be deluged by water by 2035. So looking at this, there's a deep concern that we all may share and understand. How do we address this climate change aspect? And I'm going to specifically talk about the sea level rise and how we are addressing that. If you look at the Arctic and Antarctic regions, which are covered by ice sheet and ice mass, majority of our freshwater resources are there, but they are melting. The glaciers are melting, there's ice shelves that are breaking off, they're going into the water. And as more and more of these events happen, the sea level rises. If you look at some of the predictions, they have a very wide range. The best estimate is 0.6 meters. But the range goes anywhere from 20 centimeters to 2 meters. That's a very big range for any policymaker to make a decision on what can we do to address these issues and how can we impact our communities, how can we shore up defenses in the communities. This is where our research comes in. Using data science and AI models, working very closely with polar scientists, can we harness the data to have better predictions? This is truly a place where data science and AI can have an impact. But as you can imagine, this is a very complex system as well. Lots of data, lots of heterogeneity. Let me tell you a little bit more about that. If you look at the ice sheets in any of the polar regions, Arctic or Antarctic, there is ice mass, which is the ice sheet. There is sea ice. There is ice in the middle of the ocean. Lots of different elements at play. If I just look at the ice sheet on the land mass, many things could be happening there. There could be the atmospheric factors affecting the sea mass or the ice mass. There could be melt on the surface, which gets into runoff and discharge into the water. And as those things happen, several different things start coming into play. Many complex dynamics start coming into play. How do these subcomponents and components interact with each other? And the reality is that there are many, many different scientists specializing in each of these areas, and we have to bring them all together. So it's not just an element of science bringing together the data, but also bringing together the data scientists and the polar scientists who are looking at these different parts. So clearly, there is a lot of opportunity for harnessing the data, but an opportunity of bringing people together as well from different domains. There's lots of multi-complex systems that we can bring together with data science and AI. So keeping this in mind, how do we understand these interaction components? And how do we, at the end of the day, have a better prediction and more certainty in predicting the sea level rise? As you can imagine, there are many challenges. There may be a lot of data. We all have a lot of data. But is that data adequate? Is it labeled well enough? Is it heterogeneous? How do we bring it all together? How do we make sense of it when we bring it together? Are there situations where we need domain experts to help us even understand the basic features, which is what we are seeing in reality? And then once we find the patterns and we find the results, how do we validate it with all of these different domain experts that may be involved? Having conversations across these teams as well. So as you can imagine, there are different data sets. There are different architectures. The way the data is generated. And when we come into the models, there's also the question of how are we creating these models? How are we setting these parameters? Maybe we need to learn the parameters, right? So all of these things have to be brought into the fore to do the research. So we have a lot of tools in our toolbox, but we have to choose the right tool to hit the nail on the head. Do we have a big hammer or a small hammer? What do we pick for some of these things? That will depend on factors such as whether the data is small or very large. It will also depend on factors such as whether the data is uniform, well-defined, or is it heterogeneous. And then based on that, we can decide the types of models we can pick from data science and AI, whether it's a simple analysis or whether we use more involved deep learning methods. And we are using all of these. And I'm going to talk about a few examples in here as well. There's a key thing that we have to understand when we are looking at any geospatial phenomena. When we talk about the melting ice sheets or the ocean, there is space involved and there is time involved. And this is where the importance of space comes in. In this picture, you'll see the sensors that are placed in the equatorial Pacific region, buoys that are measuring sea surface temperature. And if I look at all of them together, I can say that there's this one anomalous point that looks out of place in terms of the sea surface temperature. But in reality, what may be happening is there could be a spatial phenomena there at place, which is actually, if you dig deeper into it, you will see that there may be oscillations that are happening because of which these anomalies are happening. So the importance of space is very critical. Where you live impacts your health, for example. The same way where you are in the water, where you are in the ocean, where you are on the ice mass impacts how you study that land. The same way what time period are you in also impacts how you study it. So for example, if we look at the same data from the sensors and we look at it over a period of time, there may be patterns emerging in some time steps which deviate in other time steps. And they come back. So it's like the oscillation. This example is from the oscillations in the ocean in the equatorial Pacific region. So the same way we have to emulate this in the ice sheet area as well. So looking at this, if we consider examples of what we can do in the region in terms of data science and AI, once we are able to divide this data in terms of space and time, that's where we can start having meaningful discovery, because now the space is well defined and we can understand that this space behaves similarly as compared to the other space. And these are the phenomena present here versus elsewhere. One example is if you look at the Greenland ice sheet, the central Greenland behaves very different from the coastal Greenland because there's more melt happening on the coastal Greenland. So that's why this becomes very critical. But once we do this, we can start identifying a lot of interesting patterns. We can start identifying hotspots, such as cracks forming on the ice. We can start finding relationships across domains. So what's happening in atmospherics? What's happening in hydrology? How are they related to each other? So each domain, once we define it well, we can find patterns in that domain and start making linkages, studying overlaps and proximity. This anomaly is happening at this spot, at this time period. This is how they're related. So that's where the really exciting science starts happening. One example that we started looking at is in terms of the Antarctic ice sheet. And we saw that when we looked at anomalies in the sea ice, in the western region of the Antarctic, we found some unusual things happening over a period of time in a seasonal manner. And interestingly, these simple discords that we found or anomalies that we found also corroborated stuff that has been studied by the domain sciences. So this is kind of a first step for us to make sure that our models are working, we are able to replicate the phenomena and identify the phenomena that some of the other domain sciences are also seeing. And this is an exciting discovery for us as well. One other example I'll give you is on the Greenland ice sheet. There are thousands of flights that go over the Greenland region on these flight paths, and they take radar images. These images look something like this, where they're looking at the end glacial images or the cross-section of the ice. And each of these lines indicates how the ice formed or how the ice sheet formed. If you can trace all of these lines in the image, you can actually trace it back to the ice age in some cases. This is where data science and AI can help as well, especially computer vision, where you can take subsets of these images, label these image layers, and stitch them together to understand how the ice bed is forming. Where are the layers well-defined? Where are the layers melting? This has taken a long time for polar scientists to go into the field and analyze and things of that nature. But if we can take thousands of these images and put them through our AI algorithms, we can actually move the needle a little bit. So with this, I've shared several of these scientific examples that we are working on, where we are making progress in applying data science and AI algorithms. But there's a lot of opportunity for all of us. Not only can we do AI, data science algorithms in computer vision, spatiotemporal algorithms, data mining, anomaly detection, but there's a lot of social constructs as well, where each of us can make an impact. There's things like human trafficking, climate migration that's happening as we speak. As the sea levels rise, communities are disrupted, communities are displaced, and that's resulting into major social impacts. Each of us can look at those types of problems, make an impact. There could be scenarios where ethical and responsible AI elements will come in, social justice elements come in, so that not only are we looking at where the impact is happening, but where the impact originated. How is this chain of events impacting climate at different locations? Where is the use and where is the impact? How do we connect those dots in terms of social justice elements? So there's lots of different scenarios that you can look at. And then, of course, there's this element of mis and disinformation. Anytime you talk about climate change, there are situations where there will be believers and non-believers, and there'll be discussions on different science elements you find, especially as we have some uncertainty in the predictions that we are making. How do we validate the information that we are consuming and we are putting out as well? So information, misinformation, disinformation is, again, on all of us. How do we validate information as we become consumers of this information as well? And that is what will drive the research and education in this area, in my opinion. So with that, I want to thank you for listening, and I welcome you to visit iHarp and join us in moving the needle. Thank you so much.